a lot of marks. So it's very important for you to score your marks from question number 1, whereby it's focused on algebra. So without wasting any time, let us try to solve these questions and move on. So we have question number 1. We are given the equation. They say our equation, please mute your mic. Please mute your mic. Okay, so we are given the equation. The equation is m is equals to root of x divided by x subtract 1. This is the equation provided to us. So 1.1.1, it says to us, for which value or values of x is m, this question, undefined. Okay, so we want the value or values of x that will make this equation to be undefined. So what is that x value that will make this equation to be undefined? Now, this is what is happening. Before we can even try to answer this question, I want us to talk about a fraction. We know that if you have 0 over 1, if you have 0 over 1, what will be the answer to this fraction? It will be 0, right? If you have 0 over 2, what will be the answer to this fraction? It will be 0 still. 0 divided by anything will always be 0. But now if you have instead 1 over 0, what will be the answer to this fraction? It will be undefined. Even when you have 2 over 0, your answer will be undefined. Meaning anything x squared plus 1 over 0 will be undefined. 10 over 0 will be undefined. Anything divided by 0 will be undefined. So we want to determine the value or values of x that will make this equation to be undefined. So that means if we substitute the value of x over here, that numerical value, and then we read it with this number, if we get 0 under this fraction, therefore this equation will be undefined. So here we have a fraction that looks like this. We have root of x divided by x subtract 1. So that means we need something that looks like this, root of x divided by 0, so that we can get undefined. So let us determine the value of x that will make this thing to be 0. So what are we going to do? So that means we're going to take this thing under the fraction. So that means you're going to take x minus 1, and then we want this to be equals to how much? We want it to be equals to 0. And then we solve for x from this equation. So that means you're going to say x is equals to, we're going to transpose 1 to the other side of the equation, and then it's going to be positive 1. So that means when x is equals to 1, this fraction is going to be undefined. Let's prove to see if this answer it is correct. So if I take root of x1, remember we said x is equals to 1, and then here I'm going to substitute 1, which is my value of x. Remember, I'm substituting onto this equation. My x is 1, my x is 1. So what is root of 1? It is 1. What is 1 minus 1? It's going to be 0. And remember, anything divided by 0, it is undefined. So that means the value of x that made this fraction to be undefined, it is 1, because we see that when you substitute 1 over there, we get 0. So we determine the value of x, and this will be a 1 mark. Sometimes, just to clarify everything or for everything to make sense, it is not always the case whereby your fraction will look like this. Sometimes they can say to you m is equals to, let's say, 1 over, let me say x or whatever, x, and then here I'm going to say x squared minus 1. And they say to you, determine the values of x for which this fraction will be undefined. Always you take your fraction, your denominator. You take your denominator and you equate to 0. And then you're going to solve for what? You're going to solve for x. You transpose 1 there, it's going to be positive 1. And therefore, x is going to be plus or minus root of 1. and therefore answer will be x is equals to plus or minus 1. So when you substitute 1 when you substitute 1 over here, -1 or +1, this will make this equation to be undefined. All the time you equate this to 0 and then you solve for x all the time. So remember, it's when x is equals to 1. So now, the following question, it says to us, the very same equation for which values of for which value or values of x is this m non-real? So when you talk about the non-real, what are we talking about? So when you have a root like this, anything under the root sign, to make sense, we know that it's supposed to be positive, and then we're gonna get something over here. But anything under the root sign, when it becomes negative, therefore we're gonna have the non-real roots. We're gonna have the non-real numbers. These numbers, they do not exist. They are non-real. They are imaginary. So that means we don't want a negative under the root sign. The moment we get the negative under the root sign, we are talking about the non-real roots. But the moment we get positive or 0 under the root sign, we are talking about the real roots or the real numbers. So for which values of x will this m be non-real? When x, it is less than 0. When x is less than 0, what are we talking about? We are talking about the negative numbers. So the moment we get all of the negative numbers, we really do not care. Negative 0,1, negative 0,2, negative 0,3, as long as it is less than 0. The moment the number starts to be less than 0, therefore, this root sign, where is it? This root sign, where we're going to substitute anything which is negative over there, will make the whole equation to be non-real, because you don't want negative numbers under the root sign. Okay? I hope that was clear. And therefore, when x is less than 0, this will be our answer. Now, 1.1.1.3, it says, for which value or values of x is m now real? It's easy because now I have already explained over here that when you plug anything that is positive under the root sign, okay, when you plug it, because the thing is, this could have been real even if we substituted negative numbers, but because we have the root sign, this root sign will limit us. So that means if I substitute positive numbers under the root sign throughout, I'm gonna have the real values. So that means any number that you substitute over here except 1, okay? So you're gonna say when x is greater than 0, you will get the real numbers because we have the positive numbers under the root sign. But remember, x, in this case, we said may never be equals to +1, because that means here, x can be any value except the +1, because we know that if we substitute +1 here, it's going to give undefined. So that means x can be any value except the +1. It can be any value that is greater than 0. 1, it is greater than 0, but it is not the part of the solution, because you know that 1 makes the equation to be undefined. And therefore, this will be your 3 marks. And I hope that was clear. Now, 1.2, it says to us, factorize fully. So we are given the expressions from 1 till 4. These are the expressions. We need to factorize them. So factorization, it is very important, not only under the concept factorization. It is very important, again, when solving for x or when simplifying. So when simplifying, when solving for x, we use these basics of factorization. So, but here we are not given the equation, so we cannot solve for x. We're just going to factorize. So now 1.2.1, question number 1.2.1, we are given the expression to be 2x squared minus 4x. And they say to us, factorize fully. So when you factorize, you take out the common factor. So we have two terms. They are separated by a minus sign. So because we have two terms, this is term number one, term number two, what is common amongst these two terms? Now, let us start with equals to. We're going to say this expression is equals to what? We're going to have to take x and 2 out of the brackets, because we can see that here we have 2, here we can take 2 out of 4. So I'm going to start by taking 2. And then what else am I going to take out? It is x. I'm not going to take x squared because here I have only one x. So if I have one x, that means here this will limit this. That means I'm going to take one x. So I'm going to take one x. And therefore, what am I going to left with on this side? If I take 2 and x, I'm going to left with 1x because I took 2 and x, I'm left with 1x. And then minus this side, what am I going to left with? I took x out. I took 2. That means I'm going to left with 2. And therefore, this will be your final answer. 1.2.2, it reads as follows. Now 1.2.2, it says we have a 36 y to the power 4 subtract 1. And then here we still need to factorize this expression over here. So this is what we call difference of two squares. Okay, how do you see it's difference of two squares? Each and every time when we have a square root on this term and a square root on that term, therefore we call it a difference of two squares. So now, what is the square root of 36? Square root of 36, we know that it's going to be, I think it's 6 multiplied by 6. Yes, it's 6. So 36, it is a perfect square. Y to the power 4, it is also a perfect square. 1, it is a perfect square. Therefore, this is the difference of two squares. So you're going to open up two brackets. Now, what is the square root of 36? We said it's 6. So that means here I'm going to have 6 and 6. What is the square root of y to the power of 4? It's y2 and y2. What is the square root of 1? It's 1 and 1. Now, because it's the difference of two squares, one bracket will be positive and the other bracket will be negative. Therefore, you check, can I further factorize this? Can I factorize this? No, there's nothing common here. And this can be difference of two squares. Why? Because number one, I have positive over here. You're supposed to have negative to see whether it is a difference of two squares or not. So this is done. Now let's check this side. Can I further factorize this? Again, okay, you have minus. So you're going to think of difference of two squares. But you check that 6 have a square is a perfect square. 6 is not perfect square. So already automatically everything fails. That means this will be your final answer. And there's nothing common that you can take out. And therefore this will be your final answer. Now 1.2.3. It says to us, we have 3p squared plus 5p minus 2. Now, this is what we call quadratic. So how are we going to factorize this? Remember, here we have 2. Again, when you have something like this, you open up your two brackets, right? So this is how this actually works. I know I never taught you the basics on how to factorize something like this, but let me do it now. So how to factorize something like this is you look at the first term and the third term. You have 3 terms, term 1, term 2, term 3. So the first term, it is 3p squared. The third term, it is 2. Now, you're going to take the factors of this term. What are the factors of this term? Factors are the numbers that when you multiply them, they give you the same thing. So that means it is 3p and the p, because when you multiply, they're going to give you back 3p squared. Can you see that? So it's 3p and 1 3p. These are the factors of 3p squared. They're easy like that. Now, what are the factors of 2? It's 2 and 1. Obvious. 2 multiplied by 1 will give you back 2. So these are the only 2 factors that we can talk about. Now, what matters now is how do we put these 2 factors? Because these 2 factors, we're supposed to put them here in the brackets. So now this is what we are going to do. Okay, we're going to check whether I'm going to put my factors like this, 3p 2p and 1. Remember here you put the factors of what? Here you put the factors of 2, and then here first you put the factors of 3p squared. Okay, so these are the factors of 3p squared, and these are the factors of 2. So all right, am I going to put them like this, or am I going to put them like this? This is you asking yourself, because you really need to place them. So now what matters now, it is the middle term. So now let's see, when I multiply these factors, am I going to get 5? So 3 multiplied by 1, I'm getting 3p. 2 multiplied by p, I'm getting 2p. When I add them or subtract them, will I get 5? Yes, but only when I add them, not subtract them. So that means 3p plus 2p, I'm going to get positive 5. Can you see that? Okay, meaning these are the correct factors. We can use 3p and 2, 1. So now the following thing is, okay, where is 3p going? 3p is going to be on this bracket or on that bracket. That will be determined by the middle term. Middle term, it is a positive number. And then again, here we have negative number. So for a fact that we have negative number and there we have positive number, that means there is a bracket that is positive, there is a bracket that is negative. Let me erase this. Let me just erase this, and this, and this. So that means there is a bracket that is positive and there is a bracket that is negative because of these two signs. So where is 3p going? Now the bigger number supposed to be the one that has positive. So the bigger number, how are you going to spot out the bigger number? Remember here, you put the factors of 3p squared, okay? Here and here, here and here. So the bigger number, it's when you multiply this 3p by how much? It's when you multiply this 3p by the factor of 2, which is 2. So when you multiply it by 2, and therefore another factor of 2p, you're going to place it here. Another factor of p, that means the remaining factor will be p, will come here. And therefore this will be your final answer. You can prove it. Let's just determine the middle term only. To determine the middle term, you're going to say 3p multiplied by 2 is going to give you 6p, which is, I made a mistake. This is supposed to come here. This positive is supposed to come here. Let me just do this. And then here it's supposed to be negative. Because 3p multiplied by 2 is going to give you positive 6p. Negative 1 multiplied by p is going to give you negative p. When you add them, negative 6, positive 6 minus 1, 6 minus 1, it's 5p. Therefore, you get positive 5p in the middle term. Okay, that's how we solve this question. So now let us move to question number 1.2.4. 1.2.4, it says to us we are given this a squared over 9, open bracket 3 minus b plus b squared over 16 b minus 3. Now, how are we going to factorize this expression? This is simple as ABC. Now, this is what is happening. You have two terms, okay, separated by positive sign. You have two terms, term number 1 and term number 2 is binomial. So when you see binomial, you always figure out, can I take the common factor? Remember, here it's positive, so you can't think of difference of two squares. Yes, I can see that here we have a perfect square, and in here we have a perfect square, but for a fact that you have positive, we can't talk about difference of two squares. So that means it fails. Therefore, what are we going to talk about? Can we take the common factor? Now, here's the thing. This thing looks like it is the same thing. 3 minus b and b minus 3 looks the same. But I can see here I have 3 and then here I have b. Why not I rearrange one of the two to see if I will get the same thing? So the first thing, that not to confuse you, I can just do it step by step. So I can say a squared over 9. Maybe this one I'll keep it the same. It's up to you whether you change this or you change that. So here I have 3 minus b plus b squared over 16. Now let me change this 3, this negative 3, let me take it this side, and this positive b, let me take it to the other side. And then let me compare this and this. Now they look the same. No, they do not look the same. They look the same because it's 3, 3, b, b, but the signs are not the same. So what I will try to do is, okay, if they look the same like this, why don't I take negative out of the bracket? So that means I have a squared over 9. Here I have 3 minus b. When I take negative out of the bracket, here it's going to be negative b squared over 16. And therefore here I'm going to left with positive 3. And then there it's going to be negative b. Now I manipulated this side to look the same as this side. Again, remember, remember, we are dealing with what? We are dealing with two terms. What is common on this term and that term? We can see that 3b and 3b is a common thing in these two terms. Therefore, I'm going to take it out of the bracket. So that means if I take 3b out of the bracket, what am I going to left with here? I'm going to left with a squared over 9, this negative, and then here if I take 3 minus b out of the bracket, I'm going to left with b squared over 16 and close my bracket. Now, because I took 3 minus b as a common factor, can I further factorize this? Yes, there is a negative, and these are the perfect squares. What are you thinking of? Difference of two squares. So what is the, I'm going to open up two brackets again. I'm factorizing this. Now it is taking us back to here. You see 1.2.2, it's taking us back there. So that means here I see the difference of two squares because I have negative and then I have perfect squares. So that what is the square root of a squared? It's a and a. What is the square root of 9? It's 3 and 3. What is the square root of b? It's b and b. What is the square root of 16? It's 4 and 4. These are perfect squares. You see, remember, other bracket is positive, other bracket it is negative. And therefore, this will now then be your final answer. So now let's have a look at question number 1.3. This is simplify. I remember this is how I started to master maths. I did simplify. So now 1.3.1. 1.3.1, it says to us 3 over x subtract 5 over x to the power of 2 subtract x. Now they want us to simplify. What does simplify mean? It means we have to digest it. We have to break it down into smaller pieces. So what it is presented over here, it's very, very big. It's huge. So we're going to have to break it down with the principles of maths. Whatever laws of maths that you know, make sure that you know how to apply those laws. Okay, laws of exponents, factorization, you know, all of those things, they go hand in hand here. So let us start with the first step on simplifying this expression. So now when we simplify this expression, it is a fraction. The first thing that we want to do, we want to combine. When you are given the fractions like this, each and every time when you see a fraction and a fraction that are separated, the aim is to combine them, is to make them one fraction. But because they are not one fraction, we're going to have to combine them. But before we combine them, we take note of the LCDs. We take note of the denominators, okay? We take note of the denominators. The denominators are not the same. So that means in that case, you cannot add or you cannot, what happened? You cannot add or you cannot subtract the fractions that have different denominators. You have to change this. These denominators, you have to multiply by them. But how? Let's have a look. But before we can even do that, we can see that this can be factorized. So that means you're going to have 3 over x minus 5 over, let us take the common factor, it's going to be x. And then here you're going to left with x, and then there we're going to have to left with 1. So now let us combine these two fractions. You write down the common denominator all the times. How do you write down the common denominator? Some they can do it like this because they are always afraid. It is still fine. You're not going to get your answer wrong. You're going to have to multiply this by this. You're going to get x squared, x minus 1. It is still fine. You can do it like that. Okay, there is nothing wrong with it. But because x it is there and then x it is there, there's no need for me to multiply x and x because x is there, x it is there. So I'll just write only one x because it's common. And therefore now this is not common. It's like 1 multiplied by x minus 1. It's going to be x minus 1. Guys, it is still fine. You can do it like this, okay? You can do it like this. People are used to the effect of multiplying the denominator when they're looking for the LCD. You can say x multiplied by x and say x squared, x minus 1. It is still fine. You can multiply this and that. Okay, it is still fine. So now here, now we want to combine these two fractions. Remember, this is the A. So x will cancel x. And therefore, you're going to left with how much? You're going to left with x minus x. So that means you're going to say this 3, because this cancels this, multiply by that, which is x minus 1. And then here, you're going to say the whole thing because it's the same as this thing. X minus x1 will cancel x into x minus x1. This will cancel that. You're left with 1. 1 multiplied by 5, it's going to be negative 5. Now we combined the two fractions. Now, after combining the two fractions, let's just simply distribute. So 3 multiplied by x, it's going to be 3x. 3 multiplied by 1, negative 1, is going to be negative 3. And therefore, here we're going to have negative 5. Divide by, you can just leave it here, or you can just distribute, but let's distribute. We're going to have x squared minus x. And therefore, final answer to this question, we're going to have at the top, we're going to have 3x, negative 5, negative 3, negative 5 is going to be negative how much? It's going to be negative 6, 7, 8. It's going to be negative 8. Divide by, at the top, we have x squared minus x. And therefore, can I further factorize this? No, we cannot. Therefore, this will be your final answer. Okay, for 3 marks, this will be your final answer. Can you see how big was it? And then we had to digest it until it gets here. So this is how we factorize. So if you decide to multiply x by x, like I said, it is still fine, but you have to get to the same answer. It is still fine, but you're going to have to be careful. So that means here you're going to say x multiplied by this, x, this, because we have 1x, will cancel with 1x here. And therefore, it's going to be, we're going to have 1x, this x will, x goes how many times into x squared? It goes x times. It goes x squared times. We're going to left with 1x. So we're going to say that 1x multiplied by this. Here we're going to have 3. That 1x multiplied by x minus 1. And therefore here you're going to say this will cancel this, but here 1x will left. So we're going to have negative 5x over here. And therefore, let's see. Now, can we distribute? Yes, we can distribute. This multiplied by that is going to be 3x squared. This multiplied by that is going to be negative 3x minus 5x. Divide by x squared, x minus 1. And therefore, now let's work it out at the top. So when we work it out at the top, the like terms, it's this one and this one. So that means you're going to have 3x squared. And then this one and that one is going to be negative 8x. Divide by what? Divide by x squared, x minus 1. And therefore, what is the common factor here? It is x. So I'm going to take x out of the bracket. Here I'm going to left with 3x. And therefore, here I'm going to left with 8. Divide by, remember here, I have x squared, x minus 1. So this x will cancel only one x at the bottom. And therefore, I'm going to left with 3x minus 8 divided by, I'm going to left with 1x at the bottom, this. And therefore, now we can distribute 3x minus 8. This multiplied by that will be x squared minus x. You can see that these answers are still the same if you decide to multiply from there. Okay? Aha. I can either do it in that way. Now, the last simplify, which is 1.3.2, they say to us, we have 25 to the power of x subtract 1 divided by 5 to the power of x plus 1. They want us to simplify this expression over here. So how are we going to simplify it? It's very simple. Here, the fraction is 1. We have only one fraction, unlike here where we had to combine two fractions. So here the fraction is 1. So each and every time when you see something like that has one fraction, think of factorization. So at some point, you're going to have to factorize this and to that so that you can have cancelling. But now, yet we can't factorize something. There's nothing that we can factorize here. So what we see is we can see that we have 25 to the power of x, and then we have 5 to the power of x. So for a fact that we have 25, we can change this 25 to the smallest base of 5. So we know that 25, it is given by 5 to the power of 2 multiplied by this x. That means it's going to be 2x over there. Subtract 1. Over at the bottom, we're going to write it as it is, which is 5 to the power of x plus 1. And therefore, now again, we can see a difference of two squares, okay? So this thing can be written in this way. We have difference of two squares, okay? We have something like this, x squared minus 1. And we know that when we have x squared minus 1, x, this is the perfect square, 1, 1. Other bracket will be positive, other bracket will be negative. We have something like that, okay? So that means if we open up two brackets, what are the factors of 5 to the power of x? Going to be 5 to the power of x multiplied by 5 to the power of x, because when you multiply them, you're going to add the exponent. They're going to give you 2x. And then the factors of 1 is going to be 1 and 1. Remember, it's a difference of two squares. The other bracket will be positive. The other bracket will be negative. And therefore, at the bottom, we have 5 to the power of x plus 1. We can see that now we can cancel something after factorizing this. So that means this and this, they're going to fall off. And therefore, the final answer will be 5 to the power of x minus 1. Can you see how we simplified this? We broke it down into smaller pieces. So this is how we simplify this expression.